Everybody, it's Tyler here at P&W Bonnie Lake, checking team number 2930, Sonic Squirrels. This team already has a win under the belt a couple of weeks ago and looked absolutely phenomenal on the field. Just watched them play a couple of matches before, continuing great success as well. Take a look at Sonic Squirrels. We'll be talking about their couple elevators they have in their robot, some modifications to their drive, a really cool simulator we're going to show off, and a bit more about programming and positional control coming up here on Behind the Bumpers. This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. FRC competition season is here. Submit your favorite moments to FRC Clips of the Week by each Sunday at discord.gg/firstupdatesnow. Also, the FRC Top 25 poll is open Sunday 5 p.m. Eastern to Monday 5 p.m. Eastern, where you can vote for your top 25 teams of the week at firstupdatesnow.com/FRC Top 25. Benaya, let's start off on your robot, talking about your chassis, a little bit more about your swerve drive, some modifications, and what's gone into it. Tell me more.
Yeah, so we have these motors over here that we've flipped so we can put the frame underneath the motors and make the robot smaller. So now we call these Mark IV-I minuses because they're inverted and then flipped again.
When you were looking at selecting like a type of swerve to go with, did you consider maybe using something else other than SDS to, like, you know, because some other ones kind of have a raised areas? Because it's cool what you did. I'd love to hear more about that.
Yeah, this is only our second year using swerve, so this is our first time using it. We haven't experimented with any other versions yet, so we might think about it in future years.
And nothing against SDS at all, too. So when you were looking at your chassis size, you said you want to try to keep a minimal size on it. So when you were looking at the game, how did you kind of approach like how you wanted to build your chassis for the game?
Yeah, so we wanted to make it small so we'd be able to fit 3 robots on the charge station easier. So we went for a 28 by 30 frame and it fit a lot better.
Ethan, let's continue on the robot. Talk to me more about some of the elevators that you're running as well. I mean, like I said, I saw you in the field, just so smooth from what we've seen, and you've had great success so far with an event win. So talk to me more about what's gone into it.
Yeah, I'm happy to. So in the back here, we're using the Thrifty elevator kit that we have modified over the course of a couple comps now, based on some reliability issues that we had at event number 1. We're driving it here with a couple Falcon motors in the back over here. This side, and then a single belt drive here, and then chains, which this right here is pretty much the standard system, the standard drive system. As we get up a little bit farther up here, it's cascade rigged, as you can tell by the ropes. The spring at first we wanted to omit it, but we decided to put it on anyway because it makes it much easier to take the battery out when between matches when we're changing that out. At the Glacier Peak event, our first event, we started breaking these shoulder bolts here. So we changed out for a McMaster car solution that is much stronger in terms of the shoulder and doesn't break as often, so that's pretty nice.
When you're looking, we mentioned that there's 2 elevators in your robot, so we haven't seen too many FRC teams kind of go the route of almost like a slide route sort of thing. More common in FTC, so when you're looking at doing that, talking about how you came up with this solution and a little bit more about it.
So when we were initially looking at our constraints this year, we wanted to avoid using arms because they have some precision issues, especially in terms of teams that doesn't have as much experience with them. We have a lot of experience with elevators on our team. We're using them going back as far back to Infinite Recharge, where we used it to climb. So we're capable of doing both cones and cubes with this system. Then this piece right here, our second elevator, we call this our stinger, kind of a name we've dubbed it over time because it kind of stings out like a horizontal, right? This is driven also with a 2-stage cascading system. So we have our ropes here. We have these belts, and then to raise it up a little bit for this, as it comes out, the ropes, because they're a cascading system, it pulls out the middle stage as well as the second stage. So it ends up being pretty precise for us. We haven't had a lot of misses this year in terms of cones on the higher nodes like we've seen from some other teams.
When you're looking, speaking about cones as well, we saw how cubes interact. Is it different for how cones interact on the intake?
We have a separate roller for that. So underneath here, You want to lift it up, Keish? The part for our cubes is actually a drop-down spring actuated. It's completely passive, no motors driving it. So we decided we'd go with that because it packaged very well in this design. Initially, we had at our week 1 event, we had some stealth rollers down here, and this roller was powered. We found that added weight, and it didn't really have a benefit as far as intaking things faster. So we decided to just replace it with a passive roller instead. So this is the only active roller for cubes. As for cones, yeah, let's bring it up for cones. When we intake cones, they kind of sit in this little spot right here between this this drive bar and the front of the intake, and they're able to sit in here really nicely while we're going across the field, and it's really hard to get them out. So they stay in there well as we're driving, as we're traversing the field.
So Anna, as part of the drive team as well too, we saw on here a little bit of LED color changes going on. So I'd love to hear more about some of the driver feedback that you get behind the glass as well too. So talk to me more about what's gone into that and anything else that you want to add into from a driver experience.
Okay, yeah, so for the LEDs, we have them either purple for when we want to pick up cubes from the player station, or we have them yellow for when we want to pick up cones. And based on the LEDs, the intakes the pieces differently. And so we also have more aspects to our LEDs. So the LEDs are currently, they will be solid purple as if indicating we want a cube. And so the intake is willing to go, it activates for the cube intake rather than the cone intake. And so it spins in a different direction. And then once we have the cube, the LEDs will flash red, and then they will go back to solid purple, letting me know that I have the cube in the intake, even if I cannot see it. And so here they flash red, and then they went to solid purple, letting me know that the cube was securely into the intake. And so we're able to use stuff like this, as well as things for the cones, because for the cones we pick them up at the double substation. And so how we do that, we have driver assist that allows us to auto align at both human player stations by pressing the bumpers on our controller. The left would be for the left human player station, and the right is for the right. And so for picking up a cone, okay, the elevator would go all the way up, and then it would flash red, indicating that I have control to make the last final adjustments for intaking the cone. And then once it secures the cone, it will go back, it's yellow, it turns yellow, and then flashes green, and then goes back to solid yellow, indicating that I now have control back of the robot. This has helped me a lot with lining up for the human player station, and has saved us multiple cycles within the game.
Okay, so let's talk a little bit more about software side. You have an awesome simulator we're going to showcase, and then a little bit more on the robot too.
Yeah. For sure. So early in the season, we identified that we really want a good simulator because we have really ambitious mechanical and programming goals. So a couple of things your simulator can do is we have full simulated elevator. So as you can see, we go all the way out, up, and we also go all the way out. So we can simulate both our stinger and our elevator. We also have a fully working swerve sim right there. So we got the swerve sim from a team from 3061, and we built the elevator and stinger sim ourselves. So what this allowed us to do is actually do more complicated features such as patch generation on the fly. So that kind of takes over for the driver and gives them a direct optimized path to the human player station. So demonstrating that here, if we hit this one button here, we're able to see that the robot drives to the human player station, puts the elevator up, the driver gets the final say on when the cone is picked up, and then it detects a stall on the intake, right? And then you press the button, and it drives back for you a little bit and puts it back down, and then you're able to go back here. So once you drive back to the grid, what we can do is we're able to say, okay, I want to score a game piece now. This one's a little bit more simple. It's not patch generation, it's just a simple PID. It detects for are we on a cone mode or cube mode, and then it goes to the closest node. So let's say we picked up a cube and we hit the button. You can see it drives to the cube spot right here, and then we're able to hit score, and it goes up, and we confirm, and there you go. Cool.
So how can teams use this? Like if other teams want to try to do something like this, what do they have to do to make this?
So I'd say look for the resources. I think a swerve sim has been out there for a while. 3061 has a really good one that we like. For the elevator sim and the stinger sim, those are the elevator simulation just built in the PID. We had to do some little funky stuff to get the horizontal elevator working, but it shouldn't be too bad. Look at the PLM docs; they're always helpful. Other than that, just trial and error. It's kind of the thing there.
And let's wrap up. Talk to us about a couple more programming features on the robot
Cool.
itself.
So, we have some nice things with our motion profiles. So, for example, if we were to enable, and you can see we go up, and when we're coming back down, as you can see, we don't slam our intake on the polycarb. We have a motion profile going down. That just kind of helps us avoid a lot of damage on our robot. So, there you go.
Awesome. Well, Sonic Squirrels, thank you so much for taking the time to tell us more about your team and your robot. As we film this, you're doing absolutely fantastic here, absolutely rocking it. So can't wait to see how you do, and good luck the rest of the way. Thanks a lot.
Thank you.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Kettering University is looking for talented robotics students who want to continue learning and innovating in a hands-on, real-world experience format. Kettering University representatives will be at dozens of FIRST events this season, including the championship. Go to kettering.edu/first to see which events you can meet a Kettering University representative. FRC competition season is here. Submit your favorite moments to FRC Clips of the Week by each Sunday at discord.gg/firstupdatesnow. Also, the FRC Top 25 poll is open Sunday 5 p.m. Eastern to Monday 5 p.m. Eastern, where you can vote for your top 25 teams of the week at firstupdatesnow.com/FRC Top 25. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.